don't see Chris. I'm gonna have to double check online here in a second. Braden and Billy, Austin, Erica. I'm looking for this one. I'm looking for Christian Cruz. See Garrett online. Looking for Miraz. Avery. What now? Yes. I'm sorry. I'm trying to. I didn't get my prep period today. It's like really. I had a meeting with Cobb, and then he was running around like crazy, and then it went like through the bell, and so I was late to fourth period, and then we had a fire drill, like just for like a T-test teacher stupid stuff. Well, not stupid stuff, just drop out notices, like for students who don't come to school, period. Yeah, I've got some students I haven't seen like ever. I have a student in one of my chemistry classes that has never logged into Canvas once. No, like I only like not never. No, like just not like I don't know. I really don't know. So okay, so in the opener. I double check and make sure that I pulled everything up the right way. We talked about this yesterday. Can you tell me, don't just tell me that it's made of rock. Okay, yes, I know minerals are a specified type of rock, okay, but tell me a way that these, what you think of as gems, how minerals are formed, what occurs in order to produce something like what's in all of these boxes. It could be, okay, that's not as common as a different process. Like what would make this? Okay, it's normally igneous, but it can be metamorphic. So we talked yesterday about how when the earth cools, if it's magma and it does so over a long period of time, they form large crystals. That's what you think of. And they have colors. This one just so happens to be clear. I know you guys can't see online as I'm picking this stuff up. That's not the one. What's this one? Like this is the same as the other one I just picked up, but it's got a different color. This is actually called smoky quartz. These are my kids' rocks. I'll move my stuff over here. They don't have to come from lava and from magma though. They can come from sedimentary rock. But the ones that you guys think of like this, these are chunks of amethyst. These are igneous creations. And a lot of your precious stones, somewhere I have ruby. Here we go. This has ruby in it. It's not like what you think of to like cut a ring, but that's what this red stuff is actually ruby. They're all igneous. Okay, we are going to go over types of minerals, formation, not all like 200 and some odd types of minerals. I'm sorry, we don't have time to do that. We're going to go over generic processes. What is what hard? The assignment? Don't try to do it yet. We haven't talked about it yet. All right, does anybody want the paper version, which is right here, that did not pick it up? There's a lot of stuff that's in Canvas that you don't have to write down. Most of them come from the cooling down of the interior of the earth, and they're igneous. At least the ones that you think of. Like this is igneous. These all amethyst is igneous. This is igneous. This one I think is metamorphic. This one's definitely igneous. That's what a geode is. It's lava that has encapsulated specific elements, and it gets a pocket of water in it, which heats up, creates steam, and it sort of expands the rock like a balloon, and it forms a void where the crystals form inside, where they're not impeded. But we can find minerals in all three types of rock. And we said that there's the igneous, which comes from molten earth. There's metamorphic, which is sort of fused together different types of rocks inside the earth, but not with magma. And then there's sedimentary, which is made up of dirt that's being compressed. All of the minerals can be found in the crust, But that doesn't mean that they were all made on the surface. Most of them are made within the earth itself. They are all my glasses are disgusting. They are all inorganic, which means that they came from things that were not alive. So it's not like petrified wood. Here are the flaws. They are solids. No such thing as a liquid mineral. It may have been molten lava at one point in time, but once it's a mineral, it's a solid. Oh, that is. I was going to let me keep going. I forgot to hit the unfreeze button. You can see it online. You guys can't. They have what's called crystalline structure. I'm not talking about rocks now. We're talking about gems, minerals. My glasses are a huge. And they have a very specific chemical composition. Don't worry, I'm not going to make you guys do organic chemistry. Actually, it'll be inorganic chemistry. In fact, I'd have to look it up, and I will here in just a second, because I'm curious what the actual chemical composition of this would be with this. But I have to cheat and look at the guide, because I don't memorize all that stuff. That's what reference material is for. So if I cheat, I'll figure out where amethyst is in here. Amethyst, 86. So quartz, including amethyst, the chemical, it's a silicate. It's one silica and two oxygens. But there are sometimes different shades depending on what was around these types of quartz when they form to produce the different colors. And I got the big chunks of amethyst up there, but this and this and this, gotta have more of them in here. Oh, that's calcite. These are all different types of quartz. This one, they have different colors in them depending on the exact, okay, I gotta make sure I put them back in the right one. This is rosy quartz. This one's pink. It's a little bit better, a little bit more of a pink to it. Amethyst has that classic purple color. You've got regular clear quartz. This is citrine. Somewhere I've got smoky quartz, but it's not in this one. The different things that the mineral is forming in will help to determine their color. They do form by two major ways. The crystallization is either cooling down of molten material, that's igneous and metamorphic, those specific types, or water dissolves different minerals, different elements, moves them to an area like a lake or a pond or inside a cave or whatever, and as the water evaporates away, it leaves those crystals behind. Salt does that. Halite does that. Calcite does that. It's not from inside the earth. It's just because it was in the water took it somewhere, the water evaporated away and left those minerals in a crystal form behind. If you take a glass of water, you can do this at home, take a glass of water and put a bunch of salt in it, just stir it up, and then let the water evaporate, you're going to get huge salt crystals. The same shape as a regular salt crystal, it's just, it's big version. The exact same crystalline structure.
Is this crystallization characteristics?
I don't know how I put it on here. Crystallization, the two types. So it's either from cooling off of molten earth, so magma, okay, or you have the evaporation of water that leaves that crystallized material behind. They're still crystals. I did not finish taking it all. Well, I am so discombobulated today. It is just messed up. All right, let me double check online real quick. And yes, I have more people that are online. So, okay, I see Christian. Cruz. I see. I think I haven't taken official attendance yet online. Now, I can't remember, Christian, if you still needed to take the test. No, you did take it. In here, well, Avery's, I think, still on his cruise. So Garrett, you already know. Okay, Christian M, who I did not see online. Haley, who's not here. Okay, so of the 4 that need to take it, the one that's present knows about it. I don't know if I would risk going on a cruise right now. Seriously. But it's the boats themselves. It's the
I'm not saying, being on the boat is no danger to you.
it's the cabins. It's the I mean, I've been on a cruise before. Food was awesome, but I don't know. So, anyways, all right, so going on. We talked about this yesterday. We talked about the difference between magma and lava. Magma is within the earth, it cools within the earth, and it does so slower. It's going to make your really big crystals that have lots of pretty colors, and that's what you think of as gemstones. So this would be emeralds, rubies, amethyst, sedimentary is different. Opal is a type of a sediment gemstone. That does not form in magma. Lava is the stuff that shoots out of the volcano. And we took a look at the difference between obsidian, which somewhere I have my obsidian arrowheads. Let's see if I can find them. I think it's in this one. Yeah, it's in this one. I have a couple different arrowheads actually, but I have 2 that are made from obsidian. This one had the point broken off, but they're very, very, very sharp. This is the better one. Don't break it. I have a couple other. This one looks like it was made out of jasper. I don't know what this one, but this is jasper. I'm not sure what this one was, but they're pretty gosh darn sharp.
Yeah, for like a rock.
Mm-hmm. I have all different kinds of fossils in here. My kid started crying because she thought I was giving you guys all of her stuff. I said, no, I'm just using them as examples. She's got the those sea flowers that were around at the time of the trilobites. That's what these are. They sort of, somebody on the test said, what is that spring thing with the index fossils? That's this. They're like almost like sea anemones that stick out on the top. And then like the stem part is the part that's fossilized. There's actually 2 of them that are stuck together here. She has all different kinds of stuff in here. All right, so we talked about this one yesterday. And so the other major type is the evaporation of water. This is a sedimentary rock. Now, I don't have any opal in here, I don't think. Calcite. I don't know if that was my email or if that was. I'm so discombobulated today. Let me see if that was my email or if that was online. No, I don't think it was somebody. It must have been my email. The fast one is going to produce smaller crystals. To here. What was the other part that I put on there? Yeah, it much smaller crystals. If it forms a mineral, okay, it doesn't necessarily have to be a mineral. It could be like the pumice. That was the stuff that had all the holes in it. And then you just got to touch the obsidian arrowhead that I had up here. I don't want to mess with stuff. Somewhere I've got calcite. No. Well, this is blue calcite. Oh, crap. This is a sedimentary rock. This is not an igneous rock. And I've got no quartzes. Nope. Okay, there's too many rocks, I swear. This is regular calcite, which is clear. No, it's not glass. This is a sedimentary rock. This is not an igneous one. I don't know what all of them are as far as if they. I have to cheat and look at my field guide. Halite, very, very, very large crystals. Like I said, our regular salt, sodium chloride, that crystalline structure, that's evaporated water. And then we mine it, and then we crush it up into little bits, and then we put it on our food, and we eat too much of it. We're going to do each one of these individually. There are different things that we look at, and some of it's just it's sheer color, to identify what that mineral is. It could be their color, okay, the actual appearance. It could be how hard it is. Can you scratch it with your fingernail? Do you have to use a nail to scratch it? Will it scratch glass? Can it be scratched by anything else? How shiny is it? Luster? This is pyrite, commonly known as fool's gold. It is not gold, okay? It is iron sulfide. It looks like gold, but when I take a streak plate and I run it on the streak plate, it's not gold, it's gray. So this is streak. All it is a porcelain tile. Don't. Oh, there was nothing. I rubbed it off, and then it's not gold. Streak and rock color normally are two completely and totally different things. Cleavage and fracture. Cleavage does not mean what you think it is. Okay, this is fracture. Cleavage means it's going to form a very, very specific structure. With mica, you take your fingernail and you can lift layers off, very, very thin layers. All right, so of these three pictures, which one do you think is gold? Oh, crap. It's frozen. Which one of these three pictures do you think is gold?
The one on the left.
It's all of them. Okay, so this one on the left, gold is normally found embedded in quartz. Very, very, very commonly found with each other. This is what you think of, okay? Like the people that mine for gold and they pan for gold, that's a golden nugget. But most gold is not just like a golden chunk. It's embedded with something else. And it is more often than not found with a quartz vein. So, but color, this is an example of the appearance. It's the actual color that it looks like. And then I gave this to you in your canvas. Different colors normally have certain elements associated with them. The most common element that you are going to see was going to be iron, because iron makes up over 1/3 of the interior of our Earth. In fact, iron on this is only not listed in 3 of them. And I know that there's iron in this because this has pink, this has purple, and this has green in it. I just don't know what the other type of rock is because my sister-in-law took the sticker off with what it was, and she forgot to tell me what it was. So I have to test that one. I've already broken a couple pieces off. I don't think it has streak. No, not at all. I need to get some hydrochloric acid and see if it'll dissolve it. But your specific colors are going to be representative with specific elements. No, that's the color of the actual rock. No, streak is sometimes streak, and there's one that's on that. Sometimes streak is the same color, and sometimes it's not. Like cinnabar. Cinnabar is a gray rock, but its streak looks like cinnamon, which is why it's called cinnabar. There, I already filled in the rocks. You're just gonna put next to it if it can be scratched and how easily. The hardness scale goes from 1 to 10, 1 being the softest and 10 being the hardest. The softest stone is going to be talc. Now that's what baby powder is. Scratch it with your thumb, and that's what gymnasts put on their hand. That's what you put on a baby's butt so they don't get diaper rash. Talcum powder comes from a rock. Gypsum can be scratched by a fingernail too, but it's not like going to instantly flake off. Calcite that I have up here, if I had a penny, which I don't, because pennies are stinky. If I had a penny, I could scratch it with a penny. Now, fluorite, you can tell it's fluorite by shining a black light on it because it glows in the dark. Black light. I don't have a black light. I'm not even sure if I have fluoride up here. I think there's fluoride over there. Not fluoride, fluorite. Apatite, not hungry. I have apatite right here. This is blue apatite. I could scratch it with glass. It's actually really shiny and pretty. I could scratch it with like a, not like a nail file, but like a steel file. File. Let's see. Oh my lordy. Put my pyrite back. I got the other ones on the next slide. Still using this one? You are, aren't you? I have a lot of absentee work I gotta get done. This is 11.5, which is 11.5, 11.4, 11.3, 11.4, 11.5, 11.3, 11.6. Okay, so we've got fossils, 3. Okay, so, yeah, it's the diamonds are the yeah, you can only scratch diamond with diamonds. All right, y'all should be ready. All right, so the next ones, so still going harder, feldspar. In fact, I have a glass plate up here, and it is scratched to hell because this is how you test. This is how you test to see if it's feldspar, because it will actually scratch the glass plate. Like I said, I am literally building this class from the ground up, and it's part of it is identifying what really is in there and figuring out what else I need to order. I guess it's convenient, and this is going to sound really awful. I guess it's convenient that COVID is occurring right now as I'm doing this, because you can't touch this stuff. We're not allowed to share material. Not that I want COVID to happen. I'm not saying it that way. But the fact that I don't have the things, or at least not all of the materials that are necessary for you to be able to test these things, it's just, and I don't want to say convenient like it's a good thing, but it gives me time to be able to get everything that's necessary to do this the right way, I guess is what I'm trying to say. But yes, the diamonds are the strongest. They are the most resistant to everything. Corundum is going to be below that, and then topaz. Now you can scratch one type of a mineral with the next harder mineral. 100. This is 100. This is 80. This is micro. Well, that's weird. Why did he ask to do? I don't know. I don't know. Alrighty. Luster. It sounded like a turkey. Okay, so luster, is it have a metal type shine, or does it not have a metal type shine? And it sort of looks like the one on the right is shiny, but it's not. It's just what crystals look like. To show you a better example. So this stinks. This is sulfur. It smells like a fart. This is an example of non-metallic luster. Okay, whereas this, I don't know what this is. It is super shiny. I don't know what this stuff is. Really cool looking though. All I know is it's tag number 26. This is fool's gold. It's not gold. It looks like gold. It's called iron sulfide. If you hit it with a hammer, it will spark, and you can smell the sulfur when it happens. No, we're not beating these with a hammer. I'm going to go and find all my kids' other geodes, and she has a bunch of chunks of pyrite. Actually, it's a pyrite geode. I don't know where it went. We beat on that with a hammer. But I'm not going to let you guys break the school stuff. I'm going to order some more geodes over the break, too, and we'll pop those in class. And if you want to keep a piece, you can. That's what I was just talking about. The whole, we're not allowed to touch stuff because of COVID. And I'm literally ordering the stuff to be able to do it, because a lot of the equipment. Hello?
TV network. Get TV, internet, and phone for only $29.
Really? I don't even live in that area anymore. Okay, so All right, specific gravity is basically the object's density. We compare it against water. Some elements or minerals are extremely dense and some are not. Mercury is so dense, if you filled a swimming pool with mercury, you could walk on the surface and not fall through. I wouldn't recommend doing it because if you touch mercury, you go crazy and then you die. But you literally could walk on the surface and not fall through it. But yeah, you're not even allowed to get mercury thermometers anymore. It's toxic and it makes you go insane before it kills you. I don't know if I mentioned that in the class. It's why they call the Mad Hatter the Mad Hatter. Because hatters used to make felt out of animal fur with a mercury compound and they went cuckoo. Okay, I gotta find the right one here. I've got so many people that were gone and they're trying to catch up their grades. Just have too many things going on at the same time. I'm trying to take care of everybody. Uh-oh, I don't know what happened now, but I'm not going back to it right now. All right, this is streak. Okay, so we have a couple of interesting words with rocks. We talk about streaking and we talk about cleavage. Okay, but it's not like that. Okay, so streak, this is an image of cinnabar. It's a gray rock. It's a pretty bland gray rock. But when you rub it against a streak plate, it leaves behind powder. And that powder is cinnamon in color, which is why cinnabar is called cinnabar. Don't lick rocks, okay? Don't bite rocks. Doesn't taste like cinnamon. It's the powder that's left behind looks like cinnamon. Pyrite was the one that I just did. This stuff looks like gold. It's not gold. It has, when you see the cleavage of pyrite, you can see the cubic crystals that it wants to form. A very, very distinct pattern where it hasn't been smushed. I have no idea where my daughter's pyrite geodes are. Those were fun to break open. They weren't. Huh? These are hers. Well, not these are hers. She has a rock tumbler and everything. My kid wants to become a gemologist. Ever since she was 4. Where do you can order? Okay, so a lot of them came from, there was a mini golf place where we used to live. There was like hardly anything to do in Beaumont. It's not like this area. There's like, anyway, so there's mini golf, but there was a section where she could mine for gems. So there were these pre-done kits. And so it was like a bag of sand with rocks in it. And for a little kid, you move the sluice back and forth, like how you see people pan for gold, and all the sand would go through the bottom, and then she would get her fossils and her rocks. So that's what started her. And then I started ordering them online. And she has a rock tumbler, and she can make jewelry, and she can do all different kinds of stuff. Ever since she was little, she's 8. We've had microscopes and telescopes, and she was this big. She loves looking at critters in the microscope. And then she dropped it. $300 microscope, right off the table. I was like, child, that's why we can't have nice things. This is cleavage with rocks. Yeah, I know it has other definitions, but in rocks, this is what it is. And certain things, I'm trying to write rocks. Cleavage. All right, so, to say words. It sounds dirty, but it's not. I can get away with saying all different kinds of stuff.
Yeah, I know.
Okay, so this is what cleavage looks like in a rock. Okay, so it wants to break off. I can get my fingernail underneath one little there. It wants to break off in sheets. And you can feel it. I don't want to damage the school specimens here. Here, this is. You can get it out without breaking it. Okay, so it won't come out. Okay, so this, you can even see this itty bitty thin piece came off of this. That is what cleavage is in a rock. Now, it doesn't mean it has to be, it doesn't have to be a flat sheet. It could look more, here we go, cubic. And you guys, I built it into your, I built it into your notes because I'm not going to ask you to memorize them, but there are different shapes for it. So this one on the left, this is mica. That's what I was just holding. You can literally pull them off, very, very thin layers. This is called fracture. This is fracture, this big one up here. It's not going to make these perfectly square crystals, and I can't lift off layers. In fact, when I even have chunks break off, they don't have definite patterns, which is what cleavage is. Quartz is a really good example of this. Yeah, I do actually in this class. I can say all different kinds of words that could mean bad things, but they don't mean bad things in this class. All righty, next one. So you have, let me go back. So this next one is in your Canvas, and no, you do not need to know the different type of geometrical patterns, either with the next slide, which is talking about the different types of cleavage, or with crystalline structure, but I put them in your notes. I'm not going to test you specifically on a geometric shape. It just gives you the different patterns that you could see if you are interested in this stuff. And the different shapes, specific repeating shapes, are used to help determine what mineral you are looking at. You got it? Okay, so you have this cubic. This is what pyrite does. This is that fool's gold. This is what mica does. There's very different types that they break off in a specific pattern. So if you're interested in that, that's it. That's your stuff, okay? But I'm not going to test you on it. Crystal systems. When crystals are given wide open spaces, like the inside of a geode, which is why my kid likes geodes so much. The lava, the magma, whatever it is that's molten, encapsulates some type of, I don't know, something that's got mineral, but it's also got moisture in it. And as it's trying to harden, as that moisture that's inside is trying to steam and expand, it makes a pocket of air, and these crystals form unimpeded or not impeded. I'm not sure what the right word is I'm looking for. They grow freely inside, and they're not smushed. There are different caverns, crystal caverns that you can go to. You go down into the cave, and crystals that are bigger than you. Some of them glow in the dark. Well, you have to have black light, but they do. They glow in the dark. I haven't been to a crystal cavern in a very long time. I don't know if there are any around here. That would be something that my kid would absolutely love. I'll have to look that up. One of these years, I'm going to take her to the emerald and the diamond mines, and she might have let her go dig in the dirt. Hopefully she finds something. They're in Arkansas, not that far from here. There's ruby mines over there too.
Yeah, I think I looked, when I was like 6, and you just went to a field and dug out, and you went to a place
And you sluice it. Yep. That's, my kid loves that kind of stuff.
I mean, I got it.
They can be. The best time to go to places where you can mine, okay, is right after a very heavy rain, and sometimes just walking you can find them. There was a kid that found like a 10-carat diamond not too long ago.
Somebody's digging.
No, he was just walking, and you could see it. Like, it was on the, like, the rain washed all the dirt away, and it cleaned it off, and he just picked it up.
Yeah, but don't you think nothing's gonna be there anymore? Or do you think?
Oh, you're not going to find all of them. So, I mean, you can pay to have buckets of tailings from when they do actually dig stuff up, and like there's little pieces that are left over. I mean, you're guaranteed to find something in it. Now, is it going to be like ring quality? Probably not. But, all right, so just for your information, these are different types of crystalline structure. No, you do not need to know the geometry. You do not know that halite is going to be a cube, that feldspar is like a prism. It's just if you're interested in that, I put that on there. Now, the last bit, the special properties. There are certain things that some rocks do and others don't. If they glow in the dark, specifically a black light, it's called fluorescence. This is why fluorite is called fluorite. It's this pale green color. There's a lot of rocks that are a pale, I say rock, mineral. A lot of them that are a pale green color, but fluorite under a black light fluoresces. which is why it's called fluoride. I don't think I have any fluoride up here. I bet you I do in those though. Reactivity, some of them, if you put hydrochloric acid on them, it will dissolve them. That's how that big geode that I swear one of my chemistry kids not today, but last period chemistry kids asked me if this was a dragon's egg. I was like, you've got to be joking me. But inside, I didn't know, I was hoping that it was black calcite, which is extremely rare. I was like, man, that thing's gonna be worth money. But it has these black crystals inside, and it's got red running all in between it. And the way that I found out that it was just black drowsy quartz was I broke off a little black crystal and I stuck it in some hydrochloric acid. It did not dissolve, and that meant it was not calcite, which is a sedimentary rock, or mineral. That it was drowsy quartz, which is actually an igneous mineral. Let's see, if it has magnetic properties like magnetite or lodestones, it will attract things that have iron, nickel, and cobalt. Those are the only 3 elements that are magnetic. Some of them will distort light, and it'll give you a double or triple image. It's going to have to be clean, and it's going to have to not have any kind of opacity to it. But you can see multiple images that are behind it. Now, this is the last one, and I need to double check. I have not taken attendance. I'm about to get a phone call. I'm going to get in trouble. Let's see. Let me stop this real quick because I forgot